So we will begin now, and I'll just ask Rizwan or Bibin in the background to admit any people from the waiting room. We are now at 7:06, so it is a good time to begin. And a very good morning and a warm welcome to everyone on this splendid occasion of the finale of Teens Next Big Idea 2021. I am Kat, and I'm your host for today. And with me is Mr. Rizwan, and he is our technical host. It is our privilege to be steering today's event. Now, I would like to extend a cordial welcome to our distinguished judges and keynote speakers, Mr. Rabibu Rashid, founder and CEO of Feds, Mr. Gabriel Ruggiero, Senior Business Development Executive at Pix4D, Mr. Bibin Bobby, Director of Educational Projects in from Drone in Schools, apologies. And last but not least, to all the inspirational finalists for the day, teachers, dear parents, and all the viewers present. Before we start, let us watch a short video from Drone in Schools. So we'll ask our technical host now to play the video.
Will have on the careers of the future, and that is where we come in. We are Drone in Schools, and we organize instructor-led online workshops on drone designing, drone coding, drone building, which the students can learn at ease in the comfort of their homes. Every workshop will provide students with experiential learning to use our specially developed DIY drone kits, drone simulators, and cutting-edge interactive learning platform. This will not only help your kids to expand their knowledge about science, technology, engineering, and mathematics, but also open a whole new career path for them even before they leave school. This is your chance to give them the opportunity to apply classroom learning in real life. Enroll now for Drone in Schools programs.
Wow, this is truly inspirational. Thank you so much, Rizwan, for playing the video. Now, for the intro of the event, achievements are never an accident. It is always the result of high intention, sincere effort, and intelligent execution. It represents the wise choice of many alternatives. Choice, not chance, determines your destiny. May I request Mr. Bibin Bobby, Director of Educational Projects from Drone in Schools, to address the gathering with an overview of today's competition. Mr. Bobby, over to you.
Good morning, everyone, and thank you, Kat. Welcome to Teens Next Big Idea 2021 finale. The theme of this year, Teens Next Big Idea 2021, is to build a drone for future. What you're going to witness today is 3 months of effort put in by these amazing, talented teenagers who have been selected from 120 students from our 13 schools across the region. Today, top 10 teams from 5 schools will be presenting their drone prototype. Before we start, I would like to express my sincere appreciation to Feds Dubai, Pix4D, for the support extended to this program. Our trainers, Mr. Uwais, Mr. Priyanshu, for the guidance and the patience you have shown to our participants and the effort you have put in to help build these drones. Today, in this finale, each presentation will be judged based on presentation skill, innovation, and drone build. I welcome each one of you who are present today, especially the teachers, the parents, participating students, and others who have come to witness this event. We will be also running a public poll among the audience to select the most popular drone build after all the presentation has been completed. Well, I do not want to take too much of your time now. Once again, a very warm welcome to each one of you, and thank you for joining us. Over to you, Kat.
Thank you so much, Mr. Bobby, for that synopsis of today's event. Now, just a short reminder to all the contestants of today's event about some housekeeping rules and the rules of engagement for the virtual contest. So each student has 8 minutes to present. Each team has 8 minutes to present. That is 5 minutes presentation and 3 minutes for your project video. Presentations will be shared by our technical host, Mr. Rizwan. We will ask the students to instruct the technical host to change the slides for you. And you can do this by saying next. Teams will start the presentation when they are instructed by the host, that is myself, when they are okay to begin. So we will let you know, you may now begin, please. And all the participants will be muted for the time of the presentation and the event. You will be asked to unmute yourself when it is your time to present your part of the presentation. And as Mr. Bobby mentioned, we will have 3 winners. We will have 1 winner of popular category, and that will be based on the audience poll. We will have top 6 drones that will go to our Hall of Fame, so that's 6 teams. And the main winner, of course, of the Teens Next Big Idea Finale 2021. And the winner of the Teens Next Big Idea 2021 gets $1,000 worth of gift and prizes, along with a winning trophy and a certificate. So now, before we begin with all the presentations, we will ask our eminent judges to address the gathering. And I will hand over to Mr. Rabibou Rashid, the founder of CEO and Feds. Mr. Rabibou Rashid revolutionized the Middle East's commercial drone space by introducing drones as a service in 2014. Today, Feds is not just the #1 drone service provider in Middle East, but among top 3 in the world. Feds uses DT3 approach, drone tech, data tech, and digital transformation to provide comprehensive drone solutions across the industries that are faster, more accurate, and safer. So over to you, Mr. Rashid.
Good morning, everyone. I'm very happy to be here today. Thank you for the amazing introduction, Kat. That was too much. And I will share my screen now and tell you a bit about drones. Is my screen visible now?
Yes, it is visible. We can see it. Thank you.
Yeah. All right. So just like Kat gave us this amazing introduction. So we started here in 2014 as a drone company. So back then we realized that the market does not have a company that does what we do in a sense of providing drone services and drone data to the industry, government, anyone that could benefit from this. So we realized early how important drones can be to the economy, how many processes can be improved, and as a result, we decided to launch the event here. The company. So we decided to focus on a few applications. Obviously, as most of you knows, and why we're here, there's hundreds and thousands of things you could do with a drone, or a drone can do. But as a company, we decided to focus on aerial mapping. So I'm sure all of you know what that means, but in short, it's the process of collecting 2D imagery from the sky, from a payload on a drone, and converting this to 3D data that could be used for topographic reasons and other ways. We use drones as well for inspection. So we reduce the risk of climbing, and I will show you some imagery later on how this evolved, and monitoring. So again, like I said, there's hundreds of applications, but as a business, we decided to focus on a few verticals, and these are the ones we chose and we've been working on. So, and Dubai, as you all know, is an amazing hub to start a business. It's very welcoming to new technologies. Governments and companies here are also open to innovations. They want to see new things, they want to improve, they want to stay ahead. So that's a picture from actually Dubai that's taken by drone. So if you guys don't recognize, this is actually in Hatta, in Dubai. So that's one of the dams there. This is a very accurate map. So when you look at this, obviously you can see a picture. It's similar to what you see when you're looking from Google Maps, but the difference is resolution, the level of details. So when you zoom into this, you will see things in centimeter values rather than meters. So this is actually, the drone that you see flying was used to collect this data, and a software called Pix4D was used to process this data. And then you're left with a map that looks just like reality. So what I want to focus on is to show you what drones have done to the industry and to work. So we're going to focus on things like when you needed to do an aerial photo in the past, especially something amazing in a movie or for a country or for a huge value. Your only option was to pay thousands and thousands of dollars and hire a helicopter, hire a huge team, and somebody have to either stick out of that helicopter using camera, or you have to install a camera underneath that helicopter to see these things. Today, that's how you do it. It's just from the safety of the ground, with specialized equipment and more maneuverability. So the drone can go between things, between cars, underneath things, so it could provide you that angle. The next time you watch a movie, which I do all the time, you will start recognizing that this is a drone shot, that's a drone shot, this is a drone shot. In the past, it used to be really expensive to set up cranes to do these, pull-out views and so on. Now, you'll just start noticing everywhere. It's almost all shot by drones. Surveying. So surveying is the process of obviously, measuring the land. Anybody that is building anything, infrastructure, municipalities, utilities, everybody needs to measure things before they can start installing. If you're going to install a road, you're going to build a mall, you need to know what the measurements are. You need to know what your elevations are. You need to know what the distances are, and you have to measure this. And initially, measurement, as you would imagine, it was just that. You just go on the field and you measure by tape, you go around, and then the technology evolved to total stations. So you have somebody standing from one side, somebody setting another, marker on the other side, and then you measure that. And then we moved to GPS-based terrestrial mapping, and now we have laser scanners. But today the solution is, this is a modern surveyor. He sits behind a computer, and a drone will automatically just flies and collect data, and the actual work will happen in the office after the flight. So traditional surveyor, that's your modern surveyor. He could be sitting in a AC room, relaxed, cool down, and just doing the same job with better details. That's a sample of inspecting power lines. So I'm sure you guys have all noticed when you're driving on the highways in the UAE, all these large high voltage towers that you see left and right. These to operate properly and provide power to the whole country without interruption and without blackout needs maintenance all the time. And that's one way to maintain these drones. So first you need to inspect them, and to inspect them you need to come really close and see. Any loose bolt can cause a catastrophic damage to a line, and as a result would cause a blackout. Now, obviously, in our country, we have redundancy and we have backup lines, but you don't want to rely on redundancy. You need to have to maintain your network. And there was no way to do it safely until we got the drones again. So a pilot would stand on the ground very safe. And unlike a human that is climbing, the drone stays far enough, and it have a better point of view. It can collect from 360 and it can digitize that data. So you have a much more detailed close-up approach to your inspections. In agriculture, the drones are obviously helping. So as you all know, we need to spray pesticides to conserve crops, to have more yield. And again, it goes without saying how dangerous this is to humans, that they shouldn't be exposed to this. And today, this is how you do your spraying. You just do it safe enough, far away, and just rely on drones to do this. Archaeology is another thing that is important. When they find a dig site, it's important that they don't walk on the site before they discover what's going on, because they don't want to damage anything they find that have a huge historical value. So they used to launch balloons in the air with a camera to have a top-down view. They used to set up cranes. But again, you could all imagine how easy it is to just do it with a drone today. This is something I guess you were all expecting as well. Deliveries, this is how we receive them today. And logistics, all of it will be done by drones not long from now. So in terms of drone deliveries, the technology is there for the drone to be able to deliver you, whatever you buy online, be it food or whatever shopping you buy. The limitation is related to the infrastructure and the regulation more than anything else. But as a technology, the industry is ready to start delivering pizzas to basically your doors. And again, medical emergencies, there's a lot of applications that is being done on using drones to deliver either urgent, let's say, blood is needed between hospitals, or organ that became available and somebody needs it in 5 minutes, they cannot get stuck in traffic, or just delivering to remote areas that got cut off because of whatever reason, some natural disaster that blocked the road, and these people need urgent deliveries. And this is actually happening today. It's not the future per se, but that's another way where the drone can help. And obviously, ultimately, it's a human transportation. So I'm completely convinced that within the time frame of 10 years, we would all be driving or flying a drone to go to work or to go to school. There's about probably 40, 50 companies working on designs. This is just a sample of one. This is a concept design in collaboration between Airbus and Audi, where you could, let's say, drive your car into the edge of the city, and then it gets converted into a flying pod that takes you to your office to avoid, inner city traffic and so on. These are just, samples of things to do. I mean, obviously, the ultimate future transport machine. I don't know if you guys recognize this car or not. And besides flying things, when we're talking about mobility and transportation, it doesn't really have to fly. So you have the unmanned buses, which are experimental today. They even have one of them in Dubai right now. The Hyperloop, if you haven't heard of it, it's an underground train setup that, if installed between, let's say, Fujairah and Dubai, it can get you there in 20 to 30 minutes. So as I mentioned, all of these that was discussed, as a technology, as a design, as a concept, it already exists. We're all trying to race to get there. And to me, the topic of drones is just amazing. There's no industry, there's no vertical, there's no company, there's nothing where the drone cannot come in and help. And I'm really, really excited to see what your ideas are today, guys. So I'm going to wish you all good luck, and looking forward to hearing all of them. I think.
Thank you.
How was my time, Kat? Did I overshoot or under?
It was amazing and a truly inspirational presentation. Thank you so much, Mr. Rashad. That was really, really amazing, and I learned a lot as well. And now we will hear from Mr. Gabriel Ruggiero. And Mr. Ruggiero is also a veteran of drone technology with a background in environmental engineering. Gabriel has been working with laser scanning and LiDAR technology for years. He is a senior business development executive at Pixwoody. Pixwoody develops cutting-edge software to convert images taken by hand, by drone, by phone, or by plane into survey-grade, accurate and geo-referenced 2D mosaics, 3D surface models, and point clouds. So now over to you, Mr. Ruggiero, and we will just ask Mr. Rizwan, our host, to spotlight you, and I will ask you to unmute. If you could share your presentation with us. And thank you so much. Over to you.
Thank you for the organizers, and thank you, you guys that attended this challenge, I'd say, for not only to attend, but also to listen to this speech. Thank you, Ravi, for the previous presentations. You spoiled some information regarding Pix4D as well, and I loved the DeLorean. Thank you very much. So, drones at work. You guys have developed, and you started to develop drones. You stepped into this market somehow. Drones are flying things, I would say. And what we in Pix4D, we started to do was to put a camera on drones and then starting to create maps. Pix4D is an industry leader. It's a professional company that does software. So software related to what? Basically to what Ravi said before, topography, cadastral, 3D mapping. It's called, and it's actually coming from the niche academic field of science of photogrammetry and computer vision. So what basically a drone for us is providing is like different and multiple point of views, obliques or in the air, that with these images and ground features like texture, geometries, can lead, when there is a group of picture, can lead to create a 3D point cloud, like a 3D model. That's in a nutshell what photogrammetry is. And this is what actually Pix4D does. So the scope of my presentation is to show you some case studies or examples of the usage of drones with cameras. So images and drone images are used to create basically a lot of outputs. Some of them are orthomosaics. This is what Ravi showed you for the dam. It's a map that actually has every single pixel orthographically placed in a 2D in the map, basically. Other, very appealing are point clouds and mesh, like 3D models. Drones can also fly thermal cameras, and then consequently you have thermal maps. Georeferenced, thanks to the GPS of the drone, that can be really, really accurate. You can have georeferenced map, and then you allow measurements. The topographic, cadastral, surveying methodologies always require measurements very accurately, and volume calculations. Why? Because volume, at the end of the day, it's money, either a cost or an asset to be sold. So nowadays, drones have been used, you've seen the presentation before, but have been used for many different applications. We'll show you some case studies with it. Mining, construction, public safety are, let's say, the top three, and raising up, especially for the telecommunication industries, the advent of 5G inspections are also coming for these towers, power lines, and offshore environments. Agriculture, forensic, and drone creators, OEMs, what is called, manufacturers, are embedding our technology in their drones or in their industries to save lives, improve yields, decrease pesticides, or simply enabling their drones to fly with a photogrammetric approach. As I was saying before, stockpiles are basically assets, and it helps. Drones can really help getting the right, correct measurement and calculations directly to the field without stopping any cars or any truck, and are keeping their operations ongoing. Not mentioning the safety that is always at the top priorities of mining companies. Drones can also be used in constructions together with proper software in order to do, again, orthomosaic 2D and 3D models, but especially to monitor what is called a progress monitoring of a construction site from time 0, once you have a completely virgin area, up to the end with the skyscrapers or simply high-rise buildings or a normal villa or whatever school. The overlays here are essential for CAD modeling as well. Here in Utah, in USA, a project or company use Pix4D Cloud to basically save lives in terms of the construction of a data center with multiple contractors at the same site. They basically were building a gas line pipeline basically, and the accurate records with inspections basically prevented a rupture of the gas line, and then consequently catastrophic effects. So that's the case. The map with the overlaying utilities, you can see blue and red lines, and the tracking site progress monitoring of that construction site here on the right side of my screen. So drones are also used with images in agriculture. Images can as well, I mean, you know, the cameras that are on your smartphones are RGB mostly. We have special cameras, and the drone industries have seen special cameras called the multispectral cameras that can see things that our human view cannot see. Thanks to some filters, specific bands, specific sensors can highlight every single band of the spectrum in order to collect information to then create indexes for understanding the health of the vegetation. Especially used for spraying, as Rabi said, georeferencing maps are essential in order to properly spot the right area to spray a pesticide or a nutrient. This is a really nice, interesting case study we have done in like 2 years ago in Spain with the company that actually, Drone Korea, that actually had this goal to plant 100,000 trees from drones quickly, easily, and accurately in a really desert zone in Spain. They invented this drone and they used the Pix4D suite of software to create maps and digital elevation models to understand where to basically shoot seeds from above. Essential is to have maps in 3D, basically 3D maps and 2D digital elevation models with proper GPS and proper RGB images. Emergency response is also raising up with fires and all around floods. Basically, the drones and the images collected can lead to a proper disaster management in order to decrease the risk of the first responders that are going directly on site and to help them even in the management of the post-event. Here listed an event, like not very pleased event, but where we worked together with feds to collect data of Beirut, in the explosion of Beirut with Pix4D Cloud. So we also work on the cloud and not only on desktop software in order to do then for the purpose of this case was the damage assessment with an open source actually emergency data. Inspections, again, we have a step into this as well for telecommunication industry, industrial inspection, adding machine learning and artificial intelligence. The platform is capable to collect and extract geometries of antennas, angles, orientations directly without the human intervention. Especially, Rabi knows very well, this type of structures as well as power lines can be very, very difficult and hard to fly. So you guys have to create proper flight plans in order to compete with ours. And that's actually an interesting thing that can lead to 20 minutes flight for an antenna that is 20, 30 meters high as flying as kind of a cylinder in a completely automated way. In Cameroon, company basically dropped their inspections time from 1 day to 1 hour for a cell tower inspection, thanks to the Pix4D Inspect and the Pix4D Scan product. But then goes beyond. I mean, drones, yes, it's possible, as we are seeing everywhere in the world. Policies, regulations, authorities can limit the applications of drones, or at least can delay them. So that's also the reason why we are basically going further with cameras, with GPS connected directly over the cranes for construction site, and terrestrial applications for mobile smartphones, Android, iOS, called Pix4D Catch. So, questions. I don't think so. We need to do questions now. So I will just stop sharing my screen. That's the end of my presentation. I wish you all good luck and get us inspired as well.
Thank you so much, Mr. Ruggiero. It was really, really inspirational. And thank you for both the presentations. And now, the moment that we have all been waiting for, it is the time to start the battle for the winner of Teens Next Big Idea 2021. So we will have our first team getting ready now. I believe we will now first hear from Mohit. Just before we start, while our technical host is getting the presentations ready and is getting ready to spotlight our contestants, I will just remind all the contestants one more time. Please make sure that you remember to put your cameras on, and please make sure that you remember to let our technical hosts know to change the slides for you. So we will now hear from Mohit and team from our own school. I'll just see if we are ready. Rizwan, are we ready? Do we have Mohit?
Yes, we are ready.
We have Mohit and we have the presentation. Lovely. And can we just spotlight Mohit so that we've got him next to the presentation? There we go. So Mohit, you may begin. I think we just need to mute maybe Rizwan, the drone in school. We've got a little bit of a background there. A little bit of a feedback. Okay, that should help. All right, Mohit, over to you. You may begin, and the timer will start now.
Good morning, everyone. I'm very pleased to announce that we have made this PPT and our presentation with my teammate Juwan. I would like him to introduce our presentation.
Good morning to one and all present here. We, as part of this competition, have tried to invent something innovative that has the potential to change the world. Mohit and I have created a drone. We call it the Metal Waste Managing Drone. Next. Now let me ask you all present in this meeting a simple question. How many of you want to save Earth? How many of you want to be a superhero and protect Earth? Kind of like Superman, Fireman, or even Wonder Woman. Well, let me tell you something. It is not that hard as you think it is to change the world. It just takes a little bit of commitment from each one of you. Being citizens of the world is our responsibility to take care of planet Earth. The reason why we decided to build such a drone is because pollution, the major factor, is bringing the world closer to the verge of destruction. Mother Earth is home to all living plants and animals. The most valuable asset each one of us can take pride in. Without our planet, all life will cease to exist. In such a situation, it is our duty to take care and sustain our planet. But instead, humans are exploiting planet Earth. We are indiscriminately taking away resources from the environment without following any sustainable measures. Pollution rates have skyrocketed in the past half century. If necessary steps are not taken now, consequences will be severe. It is high time that we change our methods and protect Earth. According to extensive studies, the rates of pollution and other environmental problems continue in the same rate without any changes made. We don't have more than 100 years to stay on Earth. Hence, it's each one of our duty to take care and protect our environment before it's too late. Next.
About our drone, we have built in an arm under the drone with magnetic surface as a prototype that helps in picking up the magnetic waste whilst the drone hovers over them. But in our final version, we will have an electromagnet under the drone for efficient use. So our drone is built with a magnet underneath so it can pick up the metal waste and deposit it to wherever required. For our prototype model, we have attached a normal magnet which picks up the waste. But in our final version, we would attach an electromagnet which we would control with a transmitter so it is much more efficient and powerful. Next slide. The picture that you see in front of you are of our prototype. As you can see, there is magnetic surface that we have attached to the drone. This would go down and pick up the waste that is lying around and deposit it in places like recycling centers. Thank you. Next slide.
By Storm. We as a team decided to invent something innovative that is capable of changing the world. We have invented a magnetic waste managing drone. This drone has the capability of picking up waste simply lying on the ground, resulting in cleaning the environment. According to an extensive study, metal waste production have been increased to 25 million tons produced each year. I myself, while going for hiking in the mountains, see so much metal waste simply on the ground. These wastes are mostly non-biodegradable. Hence, such an action of cleaning non-biodegradable wastes helps in sustaining the health of the planet. Our drone includes all the necessary parts of a proper working drone, like CC3D flight controller, 1000 kV brushless motors, 30 ampere ESC, FlySky remote control transmitter and receiver, F450 quadcopter frame carbon fiber propellers. In addition, we have built in an arm under the drone with magnetic surface as a prototype that helps in picking up the magnetic waste whilst the drone hovers over them. But in reality, we will have an electromagnet under the drone for efficient use. To be honest, our journey in this process of building the drone have been packed with struggles. It was never a better process. We were able to build the entire drone with all its components in place. But then, various issues came charging at us one by one. It started with the problems during ESC calibration, then the thrust force not being able to lift up the drone, and finally, the components breaking due to lack of experience. The end of this tough journey. We did it. Our drone flies perfectly off the ground, high above into the sky. It was a moment filled with pride, and our feelings cannot be expressed through words. Our drone prototype finally fulfilled its purpose of picking up metals from the environment. As you can see, the drone is easily able to take off, and the metallic can is stuck to the magnetic arm built under our drone, just as how we planned. So we would like to conclude by thanking everyone involved for this wonderful opportunity to learn and create a well-functioning drone with the purpose of saving the world.
That is fantastic. Thank you so much, Juan, and thank you so much, Mohit. Thank you for your presentation. Are there any closing slides, any closing thoughts? I believe not. Thank you very much. And now we will have the next team getting ready. So Tanush from the Millennium School is getting ready. Before, we've got some small issues with the timer, so we will be monitoring the 8 minutes time. Let's just make sure that Tanush is here with us. So we've got his presentation ready, and let's just see if Tanush is with us and if we can unmute Tanush. I believe we've got Tanush. Tanush, remember to put your camera on. Brilliant, thank you. And your slides are ready, and you may begin. You've got 5 minutes for presentation, 3 minutes for your video. Please begin now.
Next. Good morning, everyone. I'm Tanush Shanani. I'm currently 12 years old and study in the Millennium School, Dubai, in grade 8 with the intention of becoming an aerospace engineer. While not studying, I tend to find myself conserving energy, sleeping, pursuing one of my other interests, the most prevalent among them being reading, playing, programming, or building Lego robots. Today, I'm here to introduce you to my surveillance drone, Scout. To the right is a picture of me with Scout in the scenic park, where Scout and I carried out most of our recon missions. I came up with the idea of Scout about a year ago during a family gathering. We had gone to Al Qudra Lakes, and two of us walked off in a different direction from the group to observe some birds. In our focus on the birds, we didn't notice our group leaving, and when we looked up, we found there was no one around. I wished I had a means of a quick aerial recon to see in which direction the team had gone, and the idea of trying to make a surveillance drone came to mind. I hadn't done much about the idea until this event, which provided the boost and knowledge needed for me to make Scout. Next slide. Let us take a closer look at Scout and its capabilities. Scout is designed as a quadcopter which can carry out surveillance and measurement tasks both from the air and, with some restrictions, underwater. It has two high-quality cameras with the possibility to include different types of sensors that can each be used to record or measure different parameters like temperature, pressure, chemical composition, etc. Both cameras and all sensors are able to wirelessly transmit information, photos, and videos to the receiving station within appropriate range, as well as being able to record all the data on an SD card. The drone is able to fly into dangerous or inhospitable terrain like high altitudes, locations of natural disasters, near volcanoes, and search for lost or injured people in difficult to reach places. Somewhat like when the UAE police recently used drones as well as helicopters to locate a child who had gotten lost near the Jebel Jais mountains. Scout is equipped with specially made landing gear that allows it to land on rough, uneven, or non-rigid surfaces like water. These are the yellow inflated floaters seen on the base of the landing legs in the picture of the drone on the right. It has a powerful battery which grants it a greater flying power and time. Next slide. After looking for some time, I had found a suitable kit among those offered. It was constructed using the DJI F450 frame, the OpenSize CC3D flight controller, the A2212 1000 kV brushless motor, 4 of those, 1045 carbon fiber propellers, a HRB 6000 mAh 11.1 volts LiPo battery, 32 Sky 30 ampere ESCs, a FlySky FS-IA6 receiver, and a FlySky FS-I6 remote controller. Other external parts for the aerial camera underwater camera, and 4 inflated floaters. Scout is reasonably powerful, economical, and made of easy-to-find components. This is a prototype drone, and hence all components are open. The finished product is to be fully enclosed with a lockable battery hatch. A special feature of the drone is its inflatable feet, which cushion its landing on hard or uneven surfaces and serve as flotation devices, allowing the drone to land or take off on the surface of water. The drone is equipped with 2 cameras, one for aerial surveillance and the second waterproof one for underwater surveillance. Both cameras can provide live feed when in range or record on an SD card for downloading when the unit returns to base. The aerial camera has a fixed wide-angle lens, while the underwater camera is fixed on the end of a mechanically extendable arm to the underside of the drone. These propellers can be shut off for monitoring while floating on the water. Next slide. Here are some pictures of Scout. We have a view from the front in a grey border, a view from the back in a blue border, a view from beneath in the center, and 2 views from both sides. Next slide.
Rizwan, I think the video is muted.
Short-range drone or quadcopter to be used for surveillance and by extension security. The method of operation would involve it being operated from a base station where the LiPo battery would be charged and a backup battery maintained depending on the operating distance required. The unit will stand on special inflatable feet which cushion its landing on hard and uneven surfaces and serve as flotation devices, allowing the drone to take off or land on the surface of water. There are numerous sensors and surveillance tools which can be fitted on the drone to aid and enhance its function. These include different types of cameras, IR temperature sensors, sound level measurement, and recording devices, among others. This model is equipped with 2 cameras, one for aerial surveillance and the second for underwater surveillance. The aerial camera has a fixed wide-angle lens, while the underwater camera is fixed on the end of an extendable arm to the other side of the drone. These propellers can be set up for monitoring while floating on the water without agitation of water or disruption to the marine life below. Some applications of this surveillance drone are monitoring of areas or facilities for safety and security to record or alert upon detection of unauthorized entry or movement, surveillance or monitoring of inhospitable areas where humans might be at risk, can't access, or cause disturbance to what's being observed. This would include searching in hilly areas, unstable regions, near active volcanoes, areas struck by natural calamities, as long as winds permit, structures or buildings which are damaged, wildlife monitoring in plain areas, etc. Surveillance of underwater areas. The extendable arm and camera allow the drone to view and transmit what is visible from up to 10 meters or so below the surface of water. This will allow for searching for objects below the water or monitoring marine life, considering the propellers can be switched off and will not cause them disturbance. Thank you for watching my presentation.
And thank you so much, Tanush. We're just having a little bit of a feedback there. But thank you very much for your presentation. And now we have the next team getting ready, which is Shata, Aza and Fadwa at Albasam British School. So ladies, you are getting ready. I'll ask you to put yourself on cameras. I'll request that you unmute yourself. just for when you are speaking.
Can you hear us?
Yes, we can hear you now. Okay, so it is now full hour. You may begin, please.
Okay. Hi everyone, I'm Sheta. We are the Smoke Chasers and we fly high to seek help from the sky. I'm the team leader of Smoke Chasers and we're an all-girls team from Al Basma British School. There are 3 members in our team and they are Azza, Fadwa and myself. Next. About our drone. The concept of our drone revolves around managing uncontrollable forest fires. Forest fires are very common around the world and they are very unpredictable. They can happen at any time and cause catastrophic damage. So our drone is designed to help with the problem of forest fires. If there is a forest fire, our drone will be sent to inspect the location of the forest fire and detect any smoke. It will then send a signal to the firefighters, informing them about the situation and allowing them to prepare for the situation accordingly.
Our drone will use the MQ2 smoke sensor, which enables us to detect any smoke within the given range. Our drone also has a buzzer that will make a buzzing sound once any smoke is detected, and it will send signals to the fire department immediately. One of the features of our drone is AI, artificial intelligence, as it is used to predict the possibility of the fatality of the fire, as well as how quickly and far it can spread on an hourly basis. These new findings will then be passed on to the fire department while they find ways to tackle the problem. As you can see here, the drone will be covered in a box-like structure and our propellers will be enclosed. And since our drone is covered, the smoke from the fire will not affect the drone or any of the other components of the drone. The novelty idea of our project is that it will be able to fly and hover in the air very smoothly, and the drone will be covered and the propellers of our drone will be enclosed. So if the propellers hit any object, the propellers will not break easily.
There is a minor setback to this idea. Once the drone is enclosed, there will be no air circulation around the drone, which can lead to the components heating up. And we have a solution. We have added holes to the drone's body, which will help with the air ventilation as it doesn't allow the components to heat up and helps keep the drone cool. Next. Here are the pictures of the transmitter, the FlySky transmitter we're going to be using. The elevation view of the drone, the side view, and the bottom view. At the bottom of the drone, you can see that there is an MQ2 smoke sensor and a small buzzer attached to the drone. This will help detect the smoke and send signals to the firefighters.
Next slide.
No, it's okay, go back to the previous slide. Our drone, as you can see, we are going to be using the FlySky transmitter and receiver, and we are going to be using 5-inch propellers for our drone as they are very strong and lightweight. Our drone is also going to be using a PETG frame, which has a wheelbase of around 210 millimeters. The payload weight of our drone is 50 grams, and the total weight is approximately 750 grams. In regards to our flight controller, we'll be using the KK 2.1.5 flight controller, and as you can see, we're using the smoke sensor MQ2 sensor module. Next.
Here is a picture of us working on our drone, and on the right we have a picture of our team members, Azza, Fadwa, and Sheta.
While we were working on our drone, we faced many difficulties. Our school had shut down for a few weeks due to COVID, and this made it difficult for us to work on our drone as a team. The sensors in our drone also needed to be fixed as they were not working in the beginning.
However, though, we still made it through and we all enjoyed working on it. We just want to thank the organizers, the sponsors, and the judges for this amazing opportunity. And since we've made it this far in this competition, we hope we pass through the finals, and we wish all the other teams the very best. Remember, we're the smoke chasers, and we fly high to seek help from the sky. Next. We have designed a drone to detect forest fires. Forest fires are common. Did you know more than 62,000 forest fires occur annually? Forest fires are the reasons why animals are left with no homes and no families. Additionally, they are also harmful to humans because they emit a large amount of smoke which can harm our health.
We are using MQ2 sensor to detect any smoke in the air. If a smoke is detected, an immediate signal is sent to the fire department, allowing them to investigate.
In our drone is that it uses artificial intelligence to check the intensity of the fire. This will allow the fire department to prepare a fire.
We're going to be making an aerodynamic body for the drone, so when our drone is flying or hovering in the air, it'll be able to do it very smoothly. Unfortunately, due to the COVID situations, we were not able to make it on time.
We are the smoke chasers, and remember, we fly high to seek help from the sky.
Thank you so much, ladies. Thank you, that was amazing. Thank you very much. And now we have our next contestant getting ready. Nigel, I'll just ask you to unmute. So as a reminder again, Nigel, remember to let the technical host know to change the slides for you by saying next. And now we are 8 past the hour and you may begin.
Hello everyone, this is Nigel from the Millennium School Dubai. Next slide please. A few years ago, drones for farmers meant bees, which are essential in the pollination process in their farms. Today, it means an affordable technology that they can use for precision farming. These drones are equipped with the right tools and specialized information that contributes to precision farming. They do tasks like crop inspections, pests and disease identification and control, crop mapping, crop estimation, irrigation control, and monitoring climate data. However, most farmers cannot afford drones. Here, I have a drone which is affordable by all farmers. Next slide, please. My drone flies at a low altitude to oversee crops. It is capable of carrying a total load of 1,600 grams. It can cover up to 200 meters of distance, and it has a built-in protection guard to protect the drone from shrubs and trees. Features include a pesticide spraying tank and pump, a seed dispenser, temperature and humidity sensors to record climatic conditions. These recordings are sent to a specially designed mobile app made by me. I have an altitude sensor to ensure that the drone is flying at the correct height. Lastly, a camera to record videos of the farm, which the farmer can analyze over a period of time. Next slide, please. This is a front view of my drone. It has an aluminum guard, a seed dispenser, spraying pump, sensors and mobile app, and camera. These components can be added and removed as required and to maintain the optimal flying weight of 1600 grams. Next slide please. These are some pictures of my drone. Front view, side views and top view. As you can see, the components are mounted with a velcro strap to make it easy to detach as and when required. Other uses of this drone in these COVID-19 times include sanitizing of public areas and surveillance in crowded areas. Now let's play my video of the drone flying. A dream does not become reality through magic. It takes determination and hard work. After a month of research and planning, the moment of truth has arrived. I am nervous. Will it work? Will it crash and break in two? As I switch on the drone, I have to remind myself that this is a low-flying drone and high-altitude flying is not required. Hello friends, I'm Nigel and I am very grateful for the support that you have given me. Now I am going to display the components that I have used to build this drone. Thank you for watching and I thank the DIS team and the Millennium School for giving me an opportunity to build this amazing drone. Bye!
Thank you so much, Nigel. Fantastic. Thank you very much. Okay, so Cameron, if you are ready, it is 18 past. So you may begin now. Again, ask the tech host to change the slides for you. Good luck.
Hello, I'm Osman. I'm the software engineer and the advisor for the team. And we're here to present you Liru, the most efficient and reliable way to save a drowning patient and to apply first aid.
Hey everyone, hope you're all doing well. I'm Shiroj Metani. I'm the financial manager of the group. I'm in charge of getting all the sponsorships and providing mentors for our group.
Hi, I'm Cameron Archery. So for the group, I was the mechanical engineer, and then this meant that I had to build the drone and do the wiring for the drone. I was also a communications manager. So then this meant keeping in touch with drones in schools to ensure that we had all the necessary information to complete our project to a high quality standard. Next. The original concept Liru, Lifeguard Emergency Rescue Units, is a quadcopter drone with a moderate wind class resistance and a moderate payload capacity.
All right, so the function and purpose. The essential purpose of our drone is to help save lives in situations related to people swimming in the ocean or the sea. Our drone assists lifeguards in their response time and decreases that. Annually, there are around 236,000 drowning-related deaths, and we believe that our drone can really make a difference and save even 10% of those lives. That makes a huge impact.
The drone is designed for speed. It's light and it has 4 3-bladed propellers. It can carry up to 3 kilograms of packages because of its light build. And they attach under it using a servo motor. So when the drone is off, the package can stay attached to it. This is why we didn't use an electromagnet per se, because that would still use energy to keep the package attached to the drone when it's not in use. So this ensures the drone can go the whole day assisting the lifeguard without the battery dying immediately. And using the motor, a COT inflatable life jacket or a pontoon is attached with the servo. And we have some examples of this later in the presentation. And it is dropped above the patient, so the patient can hang on to that pontoon or the life jacket until the lifeguards come to the rescue. Next.
All right, so designing and building throughout the entire process, obviously, we all as a group had a lot of fun communicating and getting to actually build the drone. It was very knowledgeable as well. So throughout the journey, we experienced several problems when it came to designing and constructing. Firstly, we had the configuration of the ESC. One of the ESCs we received in our kit was damaged, and that was a major problem as one of the propellers did not receive enough energy, which didn't allow it to spin as fast, which did not let the drone take off. Secondly, since we reside in Dubai, a place for testing was difficult to find, as in Dubai to fly drone, you need a bunch of different permits and regulations. However, in the end, we found a place, an open space where there were not enough police. So we got that working. And lastly, time management was also a problem, as due to all the broken parts and problems we gained over the course, we had to manage our time, which was difficult. However, in the end, we pulled through. Despite all these negatives, there were also several things that went very well for us. Firstly, with the construction of the drone, we understood the manual and we got the construction really well. The drone ended up working very well at the end as well. Secondly, the fundraising and sponsorship went very well. We in fact got sponsored within the first 2 days of the competition starting, which was amazing. And even better is we stayed within the $200 budget.
So throughout the competition, we all learned different things. One of the things that I learned as a mechanical engineer and also helping out a bit with Osman was configuration of different software such as Libra pilots and Beta pilots, which I believe can really help me on my journey to become an engineer. One thing interesting that we did was that we actually took a user survey on the different ideas we had. And then from that, we could understand what other people were thinking and what we should incorporate into our design. And from this, we were able to get the idea that we should create a 3D shell around our drone, since it would be used around water. So therefore, it had to be water resistant. And then, as you can see by the pie chart, many of the people actually liked the idea of a lifeguard drone. Next.
Here are some photos of the drone, and we would like to go on to the video now.
The original concept Liru, Lifeguard Emergency Rescue Units, is a quadcopter drone with a moderate wind class resistance and moderate payload capacity. The drone is designed for high speeds using 4 3-bladed propellers and rechargeable batteries for more eco-friendly design. It has the ability to carry up to 3 kg packages, and which can be attached underneath the drone using a servo motor, which is then dropped on command. The purpose of the drone is to improve water safety. With this, the lifeguard response time can be decreased, which can be the potential difference between life and death. Using the servo motor, a CO2 inflatable life jacket or floatable pontoon can be dropped above the water to the patient while further assistance arrives. Throughout our journey, we experienced several problems when it came to designing and constructing the drone. We experienced issues in the configuration of ESCs and motors. This was as a result of a faulty ESC, which we had to replace without exceeding the budget. This caused the motors to spin at different RPM, generating different amounts of thrust. As a result, the drone would flip, which led to our second problem. During the testing phase, we broke one of the propellers. This took valuable time and caused time management issues, as we had to wait a long time for new components to get shipped to our location.
When creating our drone, we wanted to be as realistic as possible, so we created a shell cover. This is because the drone would be flying near water and we didn't want the drone to be splashed by water, which would fry the flight controller. We printed this shell cover from PLA plastic and painted it red so that it would look close to the color scheme of the original model. And after attaching the release mechanism to the bottom, the drone started hitting the ground. So we had to raise the belly of the drone by printing 4 feet on the wings. This is to prevent damage to the servo upon landing and takeoff. Liru can go to the subject, drop off a life jacket and come back to the lifeguard even in very strong windy weather and in long ranges. The battery of Liru can be charged every day to ensure that first aid comes very fast with the drone's help. Liru is the best capable helper to approach a drowning patient.
The camera at the belly of the drone allows for precision drop directly above or in arm's reach of the patient. With the flick of a switch on the transmitter, the servo motor attached holding the inflatable life jacket or floatable pontoon releases, dropping it into the water. The raised legs act as shock absorbers for rough landings and further prevent damage to the drone upon landing and takeoff. Overall, this competition has been very enriching, where we've been able to develop and use our STEM skills, and we are very proud to have created a successful working prototype.
Thank you so much, Cameron, Osman and Shiraj. And we'll continue with the flow. So we'll have Arnav now. Arnav is getting ready from Gems World Academy. And I'll just check that we have Arnav here and we will make sure that he is unmuted. So Arnav, bear with us just a moment. I wonder, Rizvan, do we have Arnav in the meeting? Arnav, if you are here, can you drop us a message?
Yes, he's available and he's unmuted.
Oh, we've got, okay, all right, there we go. A lot of people. Brilliant. Thank you so much. Well then, Arnav, again, the floor is yours. Make sure to remind the host to change the slides for you. 5 minutes presentation, 3 minutes video. Good luck, and you may begin.
Thank you. Hi everyone, I'm Arnav Kadia, a grade 9 student at Gems World Academy in Dubai. Today, I would like to present my drone idea, saving lives from the sky. Next slide, please. First of all, due to my background in establishing startups, I was able to conduct significant primary and secondary market research to identify an opportunity for this drone. I determined that currently the most effective and feasible opportunity would be in the healthcare sector. Effective and efficient healthcare is vital for every single person on our planet, especially during these unprecedented times caused by the COVID-19 pandemic. This fleet of delivery drones will be capable of delivering blood, medicines, and vaccines to some of the more remote places in the world where healthcare provisions are not easily accessible. Delivering medical supplies to stranded victims will enhance the emergency medical response services worldwide. Since drones have the capability of reaching disaster scenes very quickly, they're useful medical intervention devices. This drone technology could be further extended to other medical emergencies, such as cardiac arrest, which are common symptoms of critical cases of COVID-19 and can lead to a significant increase in the mortality rate. The drone could reach the emergency scene before an ambulance arrives and provide the patient with the necessary first aid equipment to mitigate the emergency. In the long term, this drone healthcare and emergency provision system could be integrated into existing health response networks. COVID-19 has had such a pertinent impact on the entire planet in a very short period of time. Considering the struggles every single person has faced during the pandemic, I believe that it is important for us to direct technological resources such as drones towards the healthcare industry. It is our responsibility as citizens of planet Earth to not only escape the shackles of this pandemic through drone technology, but also to be better prepared for future medical crises. Next slide, please. Here are the renderings of the final CAD model of the drone, which was created using Fusion 360. Next slide, please. Now I'd like to elaborate on the specification for this drone. The drone will be a quadcopter with 4 propellers. The frame will be Hybrid X, since this frame type combines the best elements from the X frame and the H frame. A Hybrid X frame will provide the drone with both a longer body, entailing more spaces for all components, and optimal arm placement, entailing balanced performance as the distance between all motors is equal. The batteries will be rechargeable to provide the drone with the necessary thrust force to take off and deliver the healthcare supplies. It will have the capability to hold packages of up to 5 kilograms with dimensions of 300 millimeters cubed. The drone will be able to achieve a delivery range of 15 kilometers radius and will be operated by remote control. Since the drone frame will be 300 millimeters long, it will need 7-inch propellers for it to work in a long-range distance. Next slide, please. Here are images. The most distinctive aspect of the drone is the way it can actually carry a box of medical supplies. I was able to use a laser cutting machine to manufacture supports for the box. These supports were created using acrylic plastic since the material is lightweight, yet strong and durable. We'll now proceed to the project video. Hi, I'm Arnav Kadir from Gems World Academy Dubai. Today, I would like to present my drone idea, saving lives from the sky. Effective and efficient healthcare is vital for every single person on our planet, especially during these unprecedented times caused by the COVID-19 pandemic. This fleet of delivery drones will be capable of delivering blood, medicines, and vaccines to some of the more remote places in the world, where healthcare provisions are not easily accessible. Delivering medical supplies to stranded victims will enhance the emergency medical response services worldwide. Since drones have the capability of reaching disaster scenes very quickly, they are useful medical intervention devices. This drone technology could be further extended to other medical emergencies, such as cardiac arrest, which are common symptoms of critical cases of COVID-19, and can lead to a significant increase in the mortality rate. The drone could reach the emergency scene before an ambulance arrives and provide the patient with the necessary first aid equipment to mitigate the emergency. In the long term, this drone healthcare and emergency provision system could be integrated into existing health response networks. The drone will be a 4-rotor quadcopter with 4 propellers. The frame will be Hybrid X, since this frame type combines the best elements in the X frame and the H frame. The Hybrid X frame will provide the drone with both a longer body, resulting in more spaces for all components, and optimal arm placement, resulting in a balanced performance, as the distance between all the motors is equal. The batteries will be rechargeable to provide the drone with the necessary thrust force to take off and deliver the healthcare supplies. It will have the capability to hold packages of up to 5 kilograms with dimensions of 300 cubic millimeters. The drone will be able to achieve a delivery range of 15 kilometers radius and will be operated by remote control. Since the drone frame will be 300 millimeters long, it will need 7-inch propellers for it to work in the long-range distance. The number of blades per propeller will be 3 to ensure balance between efficiency, speed, and control. The various components necessary for this drone will be a brushless DC motor, multi-rotor control board, electronic speed controller, servo motors, LiPo battery, landing gear, propellers, frame, and PDU. Thank you for your time.
Thank you, Arnav. That was amazing. Well done. Thank you. And we have our next contestant getting ready, Ronak. Ronak, I've just asked you to unmute, and let's just give it a second for Rizwan to upload your presentation. In the meantime, a reminder again, 5 minutes for your presentation, 3 minutes for your video. And I can see that the presentation is almost there now. So we will just allow our tech host to make it full screen. And now Ronak is 37 past. The floor is yours. Please begin.
Thank you. Good morning, everybody. My name is Ronak Matrani. I'm in grade 10, GEM Smart Academy, and I present to you the farmer drone. Next slide, please. So here's a bit of background information around what inspired me to build this drone. So around 64% of small farms today are failing due to reasons such as improper farming methods, lack of affordability of farming capital, and many others. And around 65% of the world's farmers are in debt as they can't afford multiple machines to sustain their crops. The most basic problem a farmer faces is crop failure, and as we know, their whole life depends on their crops. It doesn't just provide a source of living to the farmers, but also a source of nutrition to them along with to all of us, because as we know, food sustains life. So why do crops fail? There are two main reasons for the failure of crops. Natural reasons such as droughts, floods, earthquakes, etc. that are way beyond our control. But also man-made reasons such as infertile soil, improper fertilizer distribution, etc. that to the major extent are under our control. In the olden days, farmers used to rely on cattle to get their work done, but this had many problems such as the maintenance of cattle, the cost of cattle, and the inefficiency of cattle because they're animals after all. They need rest, they don't work for long hours, and they may fall sick. Then came gliders, which were machines, so the world was advancing. They were more efficient, but still had their issues, such as knowing how to operate them because they're planes. The farmer had to know how to fly a plane. The maintenance of gliders, they also had limited functionality, and they required a large space to store and a large runway to take off and land. So now introducing the farmer drone, a single solution to efficient farming. Next slide, please. So the farmer drone does the functions of cattle, gliders, some functions of farmers, and more all in one. It doesn't require a pilot, it's relatively much smaller, much easier to use, and has minimal maintenance. Now the farmer drone is going to be having several attachments such as a nozzle for fertilizer and water supply, a hoe for tilling and light blowing, a compost dispenser, etc., which the farmer can easily attach or remove like Legos. Now the attachments have lots of potential in the future. Other companies can produce attachments that are compatible with this drone, making the drone more useful over time. The attachments are the key point of this drone, because most farming drones today do only a single job and they don't have any attachments, they can't be modified much. But with this drone, the attachments that people can produce to do several jobs give it a lot more potential. Farming drones don't need to fly that high, they need high power to perform farming functions, which is why this drone is aimed at more power. So, one of the main drawbacks of drones are their low battery lives, but not with this drone, because the farmer drone will be having a wind turbine and a solar panel to maximize the battery. And with these, the battery will be a whopping 3 to 6 hours per charge, depending on the climate. Programming for the farmer drone will be made very simple for the farmer to understand. This drone will be having sensors such as an infrared sensor to detect obstacles and a color sensor to know where the crops are, where the soil is, and where the drone is flying. All the farmer has to do is attach the suitable attachment, just set the drone to whatever crop he wants to cultivate, and the drone will sense the field and do the job accordingly. Now the cost of the farmer drone will be around $2,000, which is $1,500 cheaper than one of the world's cheapest tractors today. Next slide, please. So as you can see, here are a few sketches of the drone. On the left, this is a nozzle for water supply or fertilizer dispensers, and on the right is a sketch with the solar panel, a wind turbine, and that's a hoe for light blowing or cultivation. And as you can see, this hoe is easily attachable, and the farmer can attach any other attachment that he likes on the same place below the drone. Next slide, please. So here are a few pictures of the drone. On the top left is just a dummy drone. It was a prototype of what I had designed. So there's a solar panel and a wind turbine, and that is a hoe that I have built using a 3D pen. And the other 3 pictures are the real drone, which we have tested and will be explaining later on in the video. Next slide, please. Now we move on to the video.
Thank you so much. Thank you so much, Ronak. Amazing, well done. Thank you for your presentation. And now we welcome another team getting ready. We have Advia, Rohit, and Jishnu. So your presentation, I believe it is on the screen now. Let's just make sure that you are all unmuted. As a way of reminder, you have 5 minutes for presentation, 3 minutes for your video. And let's just make sure that we have all the team here. We have Adya, we have Rohit, and we have Jishnu. So it is now 44, and you may begin. Good luck.
Good morning, esteemed judges. Today we, Team JAR, will be presenting to you our project, FireX. We will begin by introducing ourselves. Next. Next slide, yeah. My name is Divya Roshan, My name is Divya Roshan and I am a student of grade 9H.
My name is Jishnu Setia and I am also a student of grade 9H.
My name is Rohit Menon and I'm also a student of grade 9H.
Next. There was once a family of 2 children, their parents and their grandparents. They were a joyful family. One day, they were watching television in the living room when suddenly a fire erupted in the kitchen. The children were quick to escape. However, their parents narrowly escaped and were left injured because of the fire. Their mother died of those injuries. The grandparents, being old and fragile, could not survive the fire. The children were left with an injured father, a deceased mother, and dead grandparents. Where were the firemen during this? The parents had called them a moment after the fire began. However, the firemen had taken too much time to reach the family. Next.
Just like this family, thousands of people across the world have had to suffer in the same manner just because they could not get access to fire services in time. In a report conducted by the US Fire Association and the Insurance Information Institute, 50,000 cases of deaths and serious injuries were caused due to fires, and billions of dollars worth of property damage have been reported. According to Statista.com, in 2018 alone, there was a property loss of $25 billion, $600 million in the United States alone. The loss of property can cause people to deplete their savings account for their daily use or take huge personal loans in order to meet their needs. As a result, people lose a lot of money that they would use in the long term. The financial issue caused by a lack of home can cause stress to people. This stress can lead to depression. If severe enough, this depression may even lead to an addiction and suicide. Due to the fires, people may lose personal items such as priceless memories and prized possessions, and so on. Fires of high danger, when not extinguished on time, can cause people to get severe injury on the skin or beneath in toxic gases, or even die. When deadly fires are not extinguished in a short amount of time, it can cause severe injuries to a person, colossal property loss, or even the death of a person. Here is where we come in. With our drone, we completely aim to eradicate such situations. Next slide, please.
So, how would the drone function? The person in danger would call the fire services. The fire services will send the coordinates to the drone via SMS utilizing Twilio API. Next, the drone will employ the latest technologies like OpenCV, a computer vision library, and Raspberry Pi to properly navigate the caller's location. Then, it will use temperature sensors to detect the location of the fire. Finally, it will use the Raspberry Pi to control a small robotic apparatus that will eject the required liquid to extinguish the fire. The specifications and components are spoken about in the video that will be shown later. Apart from this version of the drone, firemen can also use a manually controlled version. This version does not have a Raspberry Pi attached to it, and as a result, it moves faster. This version can be used for cases which require more immediate resolution than others. This is the version that we have shown in our drone demonstration video. So, why should we use this drone? This drone will reduce the number of firefighter fatalities and injuries by elevating the needs for all firefighters to work on site. The responsibilities of a firefighter would shift more towards IT. If there are too many cases and too little drones, firefighters could just solve the issue the traditional way. In this manner, the drone will ensure that firefighters can solve more cases. The process of extinguishing fire would become much faster, potentially saving millions of lives. This drone, by ensuring that fire is extinguished, saves billions of dollars in property damage. This reduces the mental stress that people would most likely face due to the loss of their homes. This mental stress could lead to issues such as depression, which may even lead to addiction and suicide.
That you know about at least one person who has faced a crisis due to fires. Fires are a major issue throughout the world. According to the National Fire Protection Association, US fire departments responding to an estimated average of 353,100 home structure fires per year from 2014 to 2008. These fires caused an annual average of 2,620 civilian deaths, 11,030 civilian fire injuries, and $7.2 billion in direct property damage. This is the issue that our drone FireX aims to solve.
This is the part of the drone that stores and releases the fire extinguisher liquid. It's connected to the lower side of the drone.
So, we have used the following components in order to create a cheap yet effective functioning drone which can perform all of its functions with efficient performance. We have used the DJI drone frame, which is AX frame with a wheelbase of approximately 200 millimeters. We have used motors with 1000 kV each. We have used FlySky controller with the Libre Pilot software in order to automatically configure the flight controller. We have used the 30 ampere ESC, which allows us to prevent overflow of charge to the motors. Overflow of charge of the motors can cause a variety of problems for the functioning of the drone, such as ruining the motors mid-flight and other problems. We have used a LiPo battery with 5000 milliamperes per hour, which can easily allow us to make the drone fly for a good amount of time. Finally, we have used the FlySky transmitter and receiver. The receiver is attached to the flight controller.
Thank you very much, Advia, Rohit, and Jishnu. Well done. Thank you for your time. And now we have last but not least, Yanjun getting ready. Yanjun, I will just ask you to unmute. And as a reminder, one more time, make sure to let the host know to change the slides for you, and you have 5 minutes to present and 3 minutes for your video. So it is now, and if we can ask you to put your camera on as well, so that we can see you. I'll just check if we have Yanjun.
Yes, we are. Let me put up his presentation. So Yanjun, you can continue after that.
Thank you so much, Rizwan.
I'm able to start the video because it says that the host has stopped it.
Let's have a look. Yanjun. I will just find you, see if we can unblock that for you. Try now?
Yes, I can.
Lovely. All right, well then, Yanjun, the floor is yours. It's 54 past, and you may begin. Good luck.
Okay. So hello, I'm Yanjun Mao. I'm grade 7 currently, and I'm in James World Academy, Dubai. Next. The purpose of my drone is a delivery drone for medical purposes. When one is sick, it is important for the doctor to be able to know what is causing the sickness. Therefore, the doctor will be able to easily find a cure to that sickness quickly. Usually, a very common way that this is done is through blood testing. Blood is drawn from the patient's body and then analyzed. However, the equipment used to be able to analyze the blood is very specific, including centrifuges and other equipments that not every hospital has access to. Now, this is apparent in developed countries like China, Dubai, and the US, and let alone the developing countries. Now, in developed countries, to be able to transport the blood samples currently, usually they have to transport it by land vehicles like cars, and sometimes they can be stuck in traffic, which wastes valuable time. Now, using a drone, this can be solved because they can take a straight line and they can avoid all the traffics. And in developing countries where paved roads are not that accessible, they can fly over rough terrains with relative ease. My drone can carry up to 9 test tubes at a time, and it is the reason it cannot carry any more is because we want to be able to make the drone very accessible to every hospital. Therefore, the cost has to be down, and this can be best used in large quantities, which can make a fleet. This is because even if one drone is lost due to technical issues or weather, the rest will not be affected. Also, the drone will have many attachment points to be able to carry many test tubes. Next slide. So this is my finished drone. It uses a hybrid X-frame, which combines the stability and large carrying capability of a H-frame and the speed and agility of a X-frame. As you can see from the bottom view, they have many attachment points on the bottom of the drone, which can be used to carry samples and during COVID times, vaccines and COVID test samples. This can also be used to carry small emergency organ deliveries and blood for patients in need. The size of my frame is 220 millimeters, and it uses a F4 flight controller. My original plan was to use a KK2.1.5 controllers. However, due to accidental short circuit when developing the drone, it resulted the destruction of one arm of the drone, which made me have to replace almost all the parts of the drone. It also has an aerodynamic front, which can help with speed and efficiency. And now we can show the video of it flying.
Yanjun, please wait, so let me put up your video so I can play that for you, okay?
小分43。
Thank you so much, Yeonjun. Well done. And now we have our ladies getting ready. So Nada, Zanaira, and Juliana, they are ready to present. Let's allow the technical host to put your presentation on. In the meantime, I will just make sure that you can unmute yourself. So you should be able to do this now. And we also have Juliana. Let's test your audio, ladies. Can we hear you?
Can you hear us?
Fantastic. Yes,
Yeah.
we can. Amazing. Okay. So we will be ready with your presentation in just a few moments. So the technical host will spotlight the presentation. I believe we have got this. So Diva Drones, the floor is yours. 5 minutes presentation, 3 minutes video. Good luck, and you may begin.
Thank you. Good morning. My name is Zara. We're the Diva Drones, and we fly to find a fire and inspire. I'm the team leader for the Diva Drones, and we're an all-girls team from Al Basma British School, consisting of Zanera, Juliana, and myself. The representation of females in the technology sector still has a long way to go before females are no longer considered the minority in tech, but we are here to change that. As we all know, fires in buildings are next. Yeah, okay, thank you. As we all know, fires in buildings are common and they result in large losses. The main reasons for, that revolve around building fires are gas leaks and failure of electronic appliances. When we were trying to figure out a useful way for our drone, we did our research and realized that we did some research and realized that surprisingly, the leading cause for deaths and fires is not skin burns, as everyone would have expected, but it is actually the inhalation of carbon monoxide. Our drone will be able to detect carbon monoxide in cities and civilized areas. It will do this using an MQ7 sensor. If dangerous levels of CO are detected, a piezo buzzer will sound and a signal will be sent to the fire department. This allows people to safely evacuate and ventilate the area, preventing them from falling victims to CO poisoning. We believe that the main function of our drone plays a vital role, as carbon monoxide is widely known as the silent killer, which basically means it is colorless, odorless, and tasteless. And therefore, us humans can't detect it very easily. Not to worry, we actually created a drone just for that job.
So now we're going to explain the components of our drone. So the wheelbase of our drone is around 210 millimeters, and the weight of the drone is around 750 grams. For the frame, we used a PETG material. For our motors, we used an RS2205 brushless motor because it's more powerful compared to brushed motors, and it has a high efficiency of around 85 to 90%. For our transmitter, we used a FlySky transmitter with a 2.4 gigahertz receiver because we can control the aircraft from a large distance. For the propellers, we used 5-inch propellers because they have a new aerodynamic design which allow for a good lifting capacity. And lastly, we used a LiPo battery. Well, why a LiPo battery? Because it's small in size and it's large in energy capacity, and it also provides fairly high charging rates, so it usually charges in an hour or less. Next, please.
Okay, thank you. The novelty of our project is that our drone and its propellers will be covered, so if they hit any object or wall while our drone is saving lives, they won't break. This is also helpful as by being covered, the smoke of the fire won't be able to damage the drone or any of its components. However, one problem is that once the drone is covered, there will be no airflow inside the components of the drone. The lack of ventilation while our drone is working could result in it overheating and maybe even burning, and it could pose risks to the drone and its functions. Our team has been able to find a way to overcome this issue. Our drone's body will have holes in it to allow the airflow inside the drone, protecting it from overheating and stop working during different possible situations that could take place in a fire and could endanger our drone and its mission. As you can see, my teammate Nara is going to show you the body of her drone. Next slide, please.
On the right-hand side, you can see me and my team working on the drone. We have Juliana, Nara, and myself. On the left-hand side, you can see a couple of views of the drone. However, this is before the aerodynamic body was added. You can also see the carbon monoxide sensor, which works in conjunction with the buzzer, and you can see the transmitter. Next, please.
Unfortunately, we had faced some issues during the competition because our school shut down multiple times due to increased COVID cases, which made the situation relatively hard for us. We also ended up breaking parts of the drone because due to lack of flying experience. However, through all these difficulties and obstacles that we faced, we all worked as a group and created this successful drone, and we completed our mission. Even though this competition is about to end, our love and passion for drones has just begun. We would like to convey our gratitude to all the judges, organizers, and sponsors for this life-changing experience. And we would like to wish everyone good luck in this competition. Once again, we're the Viva Drones, and we fly to find a fire and inspire. Thank you.
Belgium 2004. What is the cause of this fire? Pipeline explosions. India 2017. What is the cause of this fire? An oil pipeline was ruptured.
China 2013. What is the cause? Pipeline explosion.
Carbon monoxide is a gas that is found in fires and gas leaks. It is a deadly gas that is often referred to as a silent killer because it is colorless, odorless, and tasteless. Our drone is designed and equipped to detect carbon monoxide gas before it reaches deadly levels to prevent Lawrence losses. The drone utilizes an MK7 carbon monoxide sensor to measure the carbon monoxide gas levels in the air. We've also added propeller arcs to ensure that if the propellers hit any object, they do not break or get damaged. Additionally, we have added extra padding for a safer ride.
It has an embedded code that will sound the buzzer before dangerous levels of CO accumulate in an environment, giving people the chance to properly ventilate or evacuate an area.
As you can see, the ppm values are rising, which shows that there is no carbon monoxide in the air. Therefore, the buzzer is sounding.
Due to personal reasons, one of our teammates wasn't able to make it. I'm Nida.
I'm Zanera.
And we are the Viva Drones.
Thank you so much, ladies. Amazing, well done. Now, thank you to all the students.
What is the cause of this fire?
Oh, we get the video again. Thank you to all the students. Well done. It was truly, truly, truly inspirational. Now, in a few moments, we will start an online poll for all the participants of today's event to vote for the most popular drone presented. So the drone that you liked the most. We will allow for the poll to be visible for 5 minutes. During this time, please select your favorite drone by clicking on the appropriate drone on the poll. So in a few moments, our technical host will put the poll up and we will be able to vote for your favorite drone, which is very difficult to choose, I must say. I don't know if I could pinpoint it on the favorite drone. You were all very, very inspirational, everyone. And we already have the participants voting. So the competition is quite definitely there. The results are changing so quickly, it is very difficult to say at the moment. The anticipation is high. So once again, we have almost 2 minutes left now, 2 minutes and 3 seconds. We encourage everyone to cast their vote if you haven't yet for your favorite team. We're almost getting to the end of our poll. We are now at 5 minutes time, and I will just ask our host to confirm. I think we've got the team confirmed. The most popular team, according to the audience poll, was Nada's team. So congratulations, Nada and the team. Well done. That's Nada, Juliana, and Zonaira, our last ladies. Well done and congratulations to you. So that is the most favorite poll, and I believe we can all see the results now. So once again, congratulations, ladies. And now we are nearing the end of the competition. But in the meantime, as the judges have been debating on the winners, I will just ask our judges to share a few words with us about the presentations that they have seen today. So I request our judge, Mr. Rashid, to say a few words and share with us on some of the key points that he will remember from today's presentation. So over to you, Mr. Rashid.
Hi, thank you, Kav. Well, that was amazing. So I'm really surprised by you guys. Almost all of you came up with something. I took so many notes, but I'm not going to mention any teams right now or any special designs until the results come out. But very impressed with the innovation. So, and especially for how advanced you managed to get your drones to fly. I mean, all of you, one by one, that's not easy. So that's amazing. We fly them every day, and we see what the problems are. So again, extremely impressed with all of you, and please do not stop. We need minds like you. If you can do this now, we definitely want you in our business by the time you graduate. Thank you, guys.
Thank you so much, Mr. Rashid. And I will ask Mr. Ruggiero now to say a few words as well. I think we should be hopefully able to see you now. Yes, we can. Wonderful.
Yes.
And over to you.
Thank you very much. It was a pleasure, really inspiring. And as well, I mean, I had a lot of night, but you made it. So you made it. This is very nice. I mean, even when I fly drones, I enjoy so much. And yeah, I mean, sometimes it fails, it crashed, but I mean, that's just the beginning of a new start afterwards. So congratulations to everybody. Thanks a lot to the organizers. And I wish to see a lot of other applications of this.
Thank you so much, Gabriel. Thank you for these words. And now I will ask Mr. Bobby as well to share a few words with us on today's presentations.
Thank you, Kate. It is indeed an awesome day for us because we started this journey with this all amazing teams maybe 4 months before. So they have gone through multiple phases of shortlisting, finalizing, submitting of different rounds of design of drones, building the drone. It was really challenging for us as a company who organized it or had this program. It was really difficult. I would first thank the school who have participated and the teachers, especially all the school, all the teachers have put in a lot of effort and energy into it to make sure that the drone flies. Then again, some of the parents, the students are extremely good, and my trainers Again and again, I need to mention Priyanshu, who have sat across the students for hours and hours to configure the drone, help them assemble, set up. Mr. Uwais is not here today, but the amount of time and energy these trainers have put in with the students, you can imagine at this kind of situation of pandemic, how we could have managed it. Then, the best of the students we got. That's what the success of this event, Teens Next Big Idea. If any of you would have seen any good drone flying, it's 100% credit goes to the students, the participants who have really put in a lot of effort. Personally, I've been interacting to all the students and a really good job. Popular Award, it's again, that is also one of my favorite team, the all girls team from Al Bassam British School, Nada and team. It is really awesome. That's what the viewers or the audience like your drones. That's why you won this most popular category award. Now coming to the next two category, we are looking at the result and the back end and trying to figure out who would be the winner. Now, let me tell you something. We can't. All of you are winners. The 10 teams who have presented here are equally. All of you guys are the winners, because out of 110 students who have participated from 13 schools, you are the 5 schools who have come among the top 10. So, just presenting your concept here in front of the judges and in front of 100+ audience here, itself is a big achievement. So. The marks what we give you or the scores we give you may not make really 8 minutes. We can't judge you in terms of the effort you have put in, so don't go by that. But it doesn't look like we can announce the result today. Maybe we can announce the top 7 who will go to the Hall of Fame, where your drones, your concept will be put up for the public to view and vote. We will set it in a Hall of Fame for you. We can definitely decide on that. But to decide the only one winner for Teens Next Big Idea at this moment, doing this program right now, it's really tough. I'm sure that all the audience and all the judges and everyone participating, you yourself would have been a very confused stage, the same situation we are in. So we are going to hold back one more day to see the recordings again and then to decide the winner of Teens Next Big Idea. But right now, Kat will announce that drones which is going into the Hall of Fame. So Kat, over to you. Please announce the drone which is going to the Hall of Fame for today.
Thank you so much, Bipin. So as you've mentioned, in that case, we will announce the winner in the next few days to give as much time to the judges as possible to evaluate all your amazing projects. And now is the time to announce the Hall of Fame, and we actually have 7 teams, not 6. So you have been all so amazing. We have 7 teams, and the drum roll, the teams are Mohit, Juan and the team, Tanush, Shata, Aza and Fadwa, Nigel, Cameron, Osman and Shiraj, Ronak, Nada, Juliana and Zanaira. So well done to all of you. Congratulations, and congratulations really to all the participants. As Bipin said, you have put so much effort in all your projects, and we would like to take this opportunity to thank really all the individuals who have made this gathering possible. And we would like to extend our heartfelt gratitude by thanking all schools, participants, teachers and parents for continuing to ensure our event experience is as holistic and enriching as possible. The technical team for making this event possible despite our current pandemic situation. Of course, our judges and organizers who were a constant support and inspiration to all our participants. And of course, thank you to the schools, mentors and supporters for their encouragement and motivation, and to all the students who have constantly strived for their outstanding achievements. So once again, huge congratulations to our prize winners, the Hall of Fame winners, the popular category winners. Thank you to all and everyone. and may the teens' next big idea encourage you to spread your wings of creativity in this world of accelerating change. So well done to everyone one more time, and have a great day ahead. And thank you so much for participating in this amazing, amazing event.